focusing on these formulae for a minute and having a look at them and how they relate to these shapes that we've got in front of us. If we look at the first one, a rectangular prism or a cuboid, the prism is the name given to any object that's got a uniform cross-section area, which means if I were to cut this anywhere down here, as long as it was perpendicular to the side, it would have the same cross-section area. Okay? So actually a cylinder too is a prism, because if I were to cut that anywhere, it would be the same cross-section area. And for any prism, the volume is just the area of the end. So in this case n, in this case that's n. The area of the end multiplied by length. So volume, length times breadth gives me the area of this end, length times breadth does, and then times that by the length and I'll have the volume. If for the cylinder, the area of the end is pi r squared, times that by the height and volume. So I really expect you to remember the volume of the cylinder. It's just the area of the end times the length. The interesting bit though comes with this surface area, and that's what I want to focus on. The surface area of that is 2 brackets BH, B times H plus H times L plus L times B. Where does that come from? What's BH in here? Giving me the area of the end, isn't it? Why 2? 2 ends. So actually, this is made up of 2 lots of BH plus, if you want the size, that's length times height. So that's 2 lots of length plus top bottom B times length. So 2 lots B times length. Agreed? That will give you the surface area of all the ends. Now the algebra comes in. We've talked about this. I've got 3 terms in this expression. 1, 2, 3. I could factorise this, which means I can take outside the bracket an element that's common to all 3. So is there anything that's common to all 3? Right, so I can take a 2 outside the bracket. BH plus LH plus BL. I can't take any of the letters out. Why not? Is B common to all of the terms? No, it's there, but it's not there. Okay? So B is in this term and this term, but not the middle term, and so on. So actually, the number 2 is the only one that's common to all 3 terms. And if you look at that, that is the formula that's written here. So actually, algebra has been used to simplify. There's a problem with this formula, and that is that it's assuming that the cuboid you're finding the surface area is a solid cuboid. In other words, it's got 2 ends, 2 sides, a top and bottom. So if you were asked to find the surface area of an open top box, for example, then you wouldn't use this formula that's written, because it's not an open top. So you wouldn't include one of the length times breadth terms in here, so then you have 1 lot of BH because there's no top. So you've got to be very careful when you use these surface area formulas. You don't just use them blind without thinking about it, because it all depends on what you've got in the shape. Your assignment is going to be asking to look at compound shapes where you've got bits stuck on other bits. So if I was actually looking for the surface area of this, but it was attached to something, then you wouldn't include that end. So you'd only have 1 end. So you have to remember that sort of thing when you're working out the surface area. If you look at the second formula, how is that made up? See where any of the parts come from? Notably the 2 pi r squared. Yeah, that's the 2 ends, isn't it? Pi r squared is the area at the top and the bottom, so 2 lots of pi r squared. So in other words, this formula is assuming the cylinder's got 2 ends to it, it might be open. So 2 pi r squared is the top and the bottom, what about the 2 pi RH? Where does that come from? That must be the sides, mustn't it? But how is it made up? How is the 2 pi RH made up? Go on then. Imagine yourself opening out the cylinder. So what you're going to have? A rectangle. What's going to be the dimension of this side in relation to the circle? Height, 3. But what's this side? The circumference of the circle. Formula for the circumference of the circle? Pi times the diameter, or pi times 2 times the radius? 2 pi. So the formula for the circumference of the circle is pi times the diameter, or 2 pi r. Now you can see where that comes from. The area of this is 2 pi r h. So using the formula for the surface area, these ones in particular, you've got to be careful because they're made up by just adding together all the areas, assuming that all the surfaces are there. They're not always there. If we look finally at the pyramid, here, formula for volume, a third times the area of the base times the height. Okay. The surface area formula is, as you might expect, actually it's the sum of the areas of the triangles forming the sides plus the area of the base. So no base, or it's on something, and we don't want to include the base, then we'd only have the sides. If you're thinking about finding the area of a side, the pyramid, then actually that takes us back to one of the formulas you had for the area of a triangle. It's a half base times perpendicular height. So you might well have to find this perpendicular height using Pythagoras to be able to find one of these sides on the pyramid. So can you see how the problem is not as straightforward as just using the formula and banging the numbers in? You have to think about it before you apply the formula. Make sure you're applying it correctly. Questions? There's 2 others on there that you can see. Look, same sort of idea. Volume and surface area of a cone and a sphere. You're not expected to know these formulae, but if you use them enough, you get to know some of them, particularly cylinder, I expect to know that one. So now, within that chapter you turn to exercise 78 please, which is on page 164. I'm going to leave you again for a little while, have a look at some of these questions, and then we'll get together and discuss them after.